Hello again. Let's get started. D by dx of the square root of 4 minus 3x to the fifth. That's d by dx of 4 minus 3x to the half power. Remember, the square root is the 1/2 power. Now this is going back to the chain rule. So remember, we let u equal the 4 minus 3x to the fifth, and you know what? It never fails. I forget something. Sorry, I got a syntax error. I forgot my 5 there. So what we do, this is the x to the 5 here, guys. Sorry about that. I forgot my 5, and I'll save that before that way, and I'll put this back in Udemy in the correct form. I never cease to make a mistake, it seems, when I type too much. But I don't type too much. I just type so much, and this is good typing overall. I just need to be careful. So let me start over. D by dx of the square root of 4 minus 3x to the fifth. That's d by dx of the entity 4 minus 3x to the fifth, parentheses, to the half power, because the square root is the half power. And then we got to, indeed, we deploy the chain rule. We let u equal 4 minus 3x to the fifth power. So we have d by du of u to the half times now the d by dx of the interior 4 minus 3x to the fifth. And then, now remember, the 1/2 comes down. We subtract 1 from the original 1/2 right here, and we get negative half. And so this 1/2, when we execute the derivative, this half came down, and then we subtracted 1, got negative half. Subtracted 1 from this 1/2 that was here, and got this negative half that is now here. So we got that, and then times, now d by dx of this, remember the difference of the derivative is the derivative of the difference. So d by dx of 4 is just 0, that's gone. And then the d by dx of negative 3x to the fifth, that's negative 15x to the fourth. Again, the 5 comes down, multiplies into negative 3, gives you negative 15, and we subtract 1 from 5, and we get 4. So again, we're doing the power rule. We call that rule the power rule, for both here and here, by the way. And now, guys, what I do is 1/2 times, I can multiply this 1/2 here times this negative 15 here. I get negative 15 halves, and I have x to the fourth. Now remember, u to the negative 1/2, that's like having a square root of u on the bottom. It's really just down here with this 2. In a way, this is kind of superficial. You could just, if you wanted to, you could write this as you can keep the negative sign here, and on the numerator you could put 15x to the fourth all together, and on the denominator you could put 2 square root u all together. But I'll keep it in this form. You could write it in either form. Now, so moving on, so it's negative 15 halves, x to the fourth over, now we got to be honest, you do have to replace u with what u is in terms of x. So we have to replace u with 4 minus 3x to the fifth, which is what it's been being all along. So put it back in. You're just putting it back. U has served its purpose, and now we're getting them out of the way. So there's that. But now, guys, remember, a lot of times your professor will want you to rationalize the denominator. So you'll stick a radical 4 minus 3x to the fifth. You'll stick a second one down here with this first one that's already here. But when you multiply the 2, that'll give you ordinary 4 minus 3x to the fifth. That was the point of doing all this. But if you multiply the bottom by a radical, you got to multiply the top by that same radical. That's this guy right here. And so, and this times sign here is actually kind of superficial. But if you don't put it, the thing about Microsoft Word is you can't tell if this is a power of x or if this is a radical, a fourth root of 4 minus 3x to the fifth. And we don't, which it is not it is the former, not the latter. It's a power of x. It is not an index of this radical at all. In fact, this index is understood invisible too. So it's good in Microsoft Word just to put this times sign here. When you're writing it out on pencil and paper, you don't need this times sign right here. In fact, I'm willing to bet, unless your professor is particularly picky, you might could leave this one off. Well, that's his or her prerogative to be picky if they want to be. You might could even leave this one off, but you could definitely leave this one off. Really, you can leave both of them off because when things are put together, it's understood that you're timesing anyway. When there's no sign in between two terms, it's understood that you're multiplying, at least in this level of mathematics anyway. Now, when you get up to the big leagues, things can change, when you get into weird stuff, but we won't go there. So here's all this, and that's it. This is it. and we're done. Now, if you have d by dx of, now 4 minus 3x to the fifth times square root of 4 minus 3x to the fifth, remember, that's that entity to the 3/2 power, because you're adding the understood 1 here to an understood half right here, and you're getting 3/2. So you got derivative of something to the 3/2. That indicates a chain rule. So you do d by du of u. Yeah, that's kind of messy. Let's scoot that down a line. That's correct, but in messy form. Oops, I didn't want to do that. Now it's giving me trouble. It's giving me a hard time. Let's scoot this down here. So we do the chain rule, and what we're going to do is, since it's being very slow, we're doing d by du of u to the 3/2. Here we go. So d by du of u to the 3/2 times d by dx of the interior. That's what u is. So we do d by dx of this interior. So remember, you just do by power rule, d by du of u to the 3/2 is 3/2 u to the half, because if you subtract 1 from 3/2, you get half, 1/2 that is. And then again, like we did before, we get negative 15x to the fourth. Guys, what happens is we multiply 3/2 times neg 15. 3 times neg 15 is neg 45. So in the numerator, we have a negative 45. But let's just take the negative out to the side and keep positive 45 in the numerator. And the denominator, there's no one for 2 to go with. So that's just 2. And then, now guys, if this would have been like negative 15 over 7, instead of just negative 15, we'd had 2 times 7 is 14 down here. That didn't occur, however. Now, let's see, moving on. We also have the x to the fourth and the square root of u. And I keep these time sign here for clarity. They are a little superficial, true, but you run into the same problem if you do that. Microsoft Word makes it ambiguous what you mean. Now, you can get rid of this one, and you'll be fine. So if you want to get rid of that time sign, great. But anyway, now what we have here, let me move that down. That's sloppy. I don't like having broken up lines. It's just sloppy to me. Sorry, I'm picky. So what we have is we have negative 45 over 2. We have the x to the fourth. Now remember, we always need to replace u with what u is in terms of x. So we have square root, and we replace this u right here with this 4 minus 3x to the fifth here, okay? And then, so there's that. And let me create a little space there just for neatness, and we're done. That'll be all for that problem. And I'm just wanting you to get the idea of this whole business of the chain rule. And again, if you make this a square right here, again, you'd have 5/2, and you just go through the same motions. You would have negative 75 over 2 and all that good stuff. But you guys get the idea. And you know what? When I copied and pasted, I made that same mistake. That should be a x to the fifth power there, guys. And that should also, and I copied and pasted when I do the same, and that should be right there as well. And I'm sorry about that. That was a goof, a boo-boo, or a mistake, and I'm sorry about that. So that's to the fifth power, and that's to the fifth power. And sure enough, I made the same mistake right here too. I didn't make it anywhere else. Go figure. Let me go up just to make sure I didn't make that same mistake. Now it's just being downright obnoxious. I think I'm good. So yeah, I don't want to mislead you. This is always 4 minus 3x to the fifth power. We'll never be dealing with just 4 minus 3x. This is always, in this example, I should say, it's always u equals 4 minus 3x to the fifth power. Yeah, I made the same mistake here. It's just hard to catch all these, and this is kind of snowballing on me. Did I not catch it? Did I do the same thing anywhere else? All these x's should be fifth powers, and I'm sorry about that. I don't. The last thing I want to do is mislead you into thinking. I didn't catch that a minute ago. Now, I just caught that now, guys. I'm sorry. I wish I'd have caught it earlier. I just didn't. Let me make sure. Well, no, it wouldn't. I don't think it would have happened up there. It would have started. The mischief would have started down here. That's good. That's good. That's good. Everything I did is good. I just made that one little syntax typo. I don't want you to lose confidence. It's just I made that one little syntax. I forgot my fifth power, and I'm making sure that has been amended. That's all I'm doing here. So again, sorry about this, and I didn't mean to shake your confidence at all. And that was just for neatness. This was correct. I just made it neater. And yeah, I'm good. I just so there's that. And guys, I think I've got it all. I just made that those few little syntax errors, but they did need to be corrected. They do matter. I'm not saying they don't matter. They matter, but that shouldn't affect what's going on in this video. That shouldn't mess up my lesson. And I hope that helps. What I'll do is I'll stop the video here, and maybe this is a good teachable moment. Just be careful with your exponents and stuff. Go back and make sure you got everything written down correctly. I made a mistake and I didn't mean to, and it's just my humanity. But the same thing could happen to you guys. Just go back and make sure you didn't forget an exponent, forget a 5 here. It's the little things like that that can haunt you sometimes. No use in losing 2 or 3 points on a test when you don't have to, or even on a homework when you don't have to. Who wants to lose points?